Hi students, welcome back to Learning Management System. Today we will discuss third session of the first unit, pointers and dynamic memory allocation of the subject data structures using C. Dear students, in third session we will be discussing these many concepts, that is pointer arithmetic operations, rules of pointers arithmetic, pointers and arrays, and pointers and two-dimensional arrays. We will discuss these concepts. Dear students, pointer variables can be used in expressions and arithmetic operations. As you know, normal variables can be used in arithmetic operations. Similarly, we can also use pointers in arithmetic operations. So what are the arithmetic operations? Arithmetic operations include addition of two numbers or two variable values, subtraction from each other, multiplication of two numbers, and division of two numbers. And combination of these operations will be expressions. Hence, pointers can be used in both expressions as well as arithmetic operations. Okay, students. So here it is one simple example how pointers can be used in arithmetic operations. Here I declared variables integer type x, y, sum, difference, product, and quotient, where x and y value are initialized as 10 and 20 respectively. And I have taken two pointers p1 and p2, where p1 is initialized with the variable x and p2 is initialized with variable y. Here I am performing the operations. Arithmetic operation, sum equal to p1 into p2, difference equal to p2 minus p1, product p1 into p2, quotient p2 divided by p1. So let me demonstrate this example through C program compiler. Students, here it is the code written in C program. Yesterday it is written double. Let me delete this. Okay, fine. So int x, y, sum, difference, product, quotient, x equal to 10, y equal to 20. Int p1 and p2, star p1 and star p2. P1, p2 are two pointers. Line number 8, it is the initialization of variables to the pointers. Here it is the first expression, that is addition of two pointer variables. Similarly, this is subtraction. Line number 11 it is product, and line number 12 it is quotient, that is division. So you carefully observe the 12, line number 12, that is after slash, that is division operator, there should be space, otherwise it will consider it as comment. You know how to write the comment in C. See the changes here. If I don't give the space, so slash star followed by the sentences are considered as comment. Okay, students. So division operation will not be accomplished. That is why take care of writing this properly. After slash, there should be space, then followed by pointer. Okay. So now let me run this. What is the output, expected output? So sum of this one will be p1 into p2. What is the p1 pointing? P1 is pointing to 10, p2 is pointing to 20. So p1 plus p2, students, how much? I expect this is to be 30. Then difference p2 minus p1, 20 minus 10, this will be 10. Product of these two, 10 into 20, 200, and 20 divided by 10, that is 2. Okay. So if this program is correct, then the same output will be displayed. Now let me run this program. Now you can check the output. Sum is 30, difference is 10, product is 20. Sorry, product is 200 and quotient is 2. Understood, students? How we can perform arithmetic operations on pointers. Okay, students. So this is one simple example of arithmetic operations of pointers. Fine. So C allows us to add integers to or subtract integers from pointers as well as to subtract one pointer from another. ಅಂದ್ರೆ ಈಗ ನಾವೇನು ನೋಡಿದ್ವಿ, ಎರಡು ಪಾಯಿಂಟರ್ಸ್ ಅರ್ಥಮೆಟಿಕ್ ಆಪರೇಷನ್ಸ್ ಅನ್ನ ನೋಡಿದೀವಿ, ಎಡಿಷನ್, ಸಬ್ಸ್ಟ್ರಾಕ್ಷನ್, ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್. ಸೊ 2 ಪಾಯಿಂಟರ್ಸ್ ವೇರಿಯೇಬಲ್ ಹೊರತಾಗಿಯೂ ನಾವು ಇಂಟಿಜರ್ಸ್, ಡೈರೆಕ್ಟ್ ಕಾನ್ಸ್ಟಂಟ್ ಇಂಟಿಜರ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ನಾವು ಪಾಯಿಂಟರ್ಸ್ ಜೊತೆ ಆಡ್ ಮಾಡಬಹುದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ p1 plus 4 or p2 minus 2 or p1 minus p2. ಸೊ ಈ ತರ ನಾವು ಆಪರೇಷನ್ಸ್ ಅನ್ನು ಪರ್ಫಾರ್ಮ್ ಮಾಡಬಹುದು. ಸೊ ಇಲ್ಲಿ ಕೇರ್ಫುಲ್ ಆಗಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಲಾಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಸ್ಟಾರ್ p1 ಅನ್ನು ನಾವು ಆಡ್ ಮಾಡಿದ್ವಿ, ಸ್ಟಾರ್ p1 ಅಂಡ್ ಸ್ಟಾರ್ p2. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ವೇರಿಯಬಲ್ ವಿಚ್ ವಾಸ್ 10 and 20. ಬಟ್ ಹಿಯರ್ we are not taking star p1. Here just we are taking p1 plus 4. Meaning of this one is we are adding the integer 4 to the address where p1 is pointing. For example, if address ಅನ್ನು 1000 ಇತ್ತಂದ್ರೆ we are adding to that to the 4, which results in again it shifts to 1004. ಅಂದ್ರೆ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಏನಿರುತ್ತೆ ಅದನ್ನು ಚೇಂಜ್ ಆಗುತ್ತೆ, 1000 ಇಂದ 1004 ಗೆ ಪಾಯಿಂಟ್ ಮಾಡುತ್ತೆ. Similarly, we can subtract pointers an integer from the pointer, or we can subtract two pointers from each other. This is allowed. And suppose p1 and p2 are both pointing to the same array. One array ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ x ಅನ್ನೋ ಒಂದು ಅರೇ ಇದೆ, and to that array p1 and p2 are pointing, then p2 minus p1 will give the number of elements between p1 and p2. ಸೊ ಇವು ಅಡ್ರೆಸಸ್ ನಡುವೆ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇದೆ ಅಂತ ಅನ್ನೋದೊಂದು ಡಿಫರೆನ್ಸ್ ಅನ್ನು ಕೊಡುತ್ತೆ. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಿಸ್, we can also use shorthand operators with the pointers like increment and decrement. p1 plus plus, that is post increment, minus minus p2. So students, you learnt in the C language types of these unary operators like pre-increment, post-increment, pre-decrement, post-decrement. Okay, so these types of operators can also be applied on pointers. Again, one more shorthand expression, sum plus which is equal to star p. This is equal to sum equal to sum plus star p2. This expression is similar to this one. So we can use such type of expressions also. These are valid expressions on pointers. Apart from this also, we can apply relational operators or relational expressions on the pointers. So what are the relational operators? Like greater than operator, less than operator, equal to operator, or not equal to operators. So when we use the relational expressions, when there is a comparison between two numbers or two pointers, there we use the relational operators. So such type of relational expressions are valid on the pointers. Okay, students. So I will demonstrate you this one along with this increment and decrement. Okay. So as of now, just to remember these things that arithmetic operations can be performed on the pointers. Shorthand operators can also be applied on the pointers. Along with that, this relational expression or relational operators can also be applied on pointers. So you can ask that. So these are the things or operators that can be applied on the pointers. What are the operators which cannot be applied on the pointers, or what type of expressions are not allowed on pointers? So simply such type of operators are not allowed. For example, dividing one pointer with another pointer, or multiplication of two pointers, or dividing a pointer by integer number. So you can see the difference. We can apply the arithmetic operations on pointer values, not on pointers. Keep in mind that I repeat it. Pointer arithmetic operations can be performed on pointers values and not on pointers. So ಇಲ್ಲಿ pointers ಅಂದ್ರೆ ಏನು? Memory addresses. Pointer values ಅಂದ್ರೆ ಏನು? The variable which is having the value. So in our example ಅಲ್ಲಿ ನೋಡಿದೀವಿ. For example, come back to the example. So here this is having the address of the x, whereas star p1 is having the value of the variable, right? So we can perform the arithmetic operations on pointer values. So ಇಲ್ಲಿ pointer values ಇದೆ ಇಲ್ಲಿ star p1 star p2 ಇವೆಲ್ಲ values ಅನ್ನು ನಾವು ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. So this is equivalent to p2 means 20 minus 10. Okay, but pointers ಮೇಲೆ ನಾವು ಡಿವಿಷನ್ ಆಪರೇಟರ್ ಆಗಲಿ ಅಥವಾ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಪರೇಟರ್ ನಾವು ಅಪ್ಲೈ ಮಾಡೋಕೆ ಬರೋದಿಲ್ಲ. I will show you this through the demonstration of example, demonstration of a program. Let me write the code. Now look at this program. Int x y is some difference. Okay, these variables are of last program variables. Let me remove this. Now p1 points to x, p2 points to y, and I am printing the address of the x and y through the pointer p1 and p2. After operation, that is I am applying p1 plus 4, meaning is I am adding 4 bytes to the memory of x, that is to which p1 is pointing. Also I am subtracting an integer from the p2 and also p2 minus p1. So let me take one more pointer. So here you can see what is the address of p1. Last numbers you check it 3000 and p2 2996. Okay, after p2 p1 is allocated 2996 plus as it is, as this is the integer type, so 4 bytes are added, so 3000. After operation I am adding plus 4, right? So to this 3000 12 bytes are added. Similarly 2 bytes are removed from the last existing pointer address, that is 3000. Last 3000 is the memory address from which I am subtracting 2 bytes. That is 2 bytes means how much? 8. 8 number is subtracted. That is from, if you remove from this 300, how much it will be? 292. Like this, we can perform such type of operations on the pointer. Okay, students. Now you see this example carefully. Integer x and y, pointer p1, p2. I have taken p1, p2 pointers and pointing to x and y. P1 is pointing to x and p2 is pointing to y. So first I am printing the address of the x and y, that is p1 and p2. I am printing the address of x and y through the pointers p1 and p2. After operation, I am applying unary increment operator on both the pointers, plus plus p1 plus plus p2. After this operation, what will be the address p1 p2? This statement gives the, after increment, what is the address. Next, after decrement, p1 and p2. So now let me run this program. You carefully observe the output. So now see, students, first p1 is how much? You observe the last line addresses. See, last 3 digits 568 p1. As memory will be allocated contiguously, hence these pointers are of type integer type, and each pointer takes 4 bytes of memory. So after 568, 4 is added to this existing memory address, which results 572. Right? Getting, students? 68 plus 4, how much? 72. From where we are getting 4? 4 because pointer data type is integer and integer takes 4 bytes of memory. So this is before applying the operations 568 and 572 to the P1, P2 respectively. After applying the operations, what operations I applied? Increment. So P1 is what? 568, to that 4 bytes are added. So P1 572. Now value is 572. Then plus plus P2. So last value of P2 was 572. To that 4 bytes is added. So after adding 572 to the 4 number, you will get 76. Getting the point, students? Next. Again, I am decrementing the pointers addresses. Minus minus P1 means what? 4 bytes are minus. Hence, last value of P1 is what? 572. 572 minus 4, again 568. And what is the value of P2? 576 minus 4, 572. Understood, students? So in this way, we can apply the unary operators, that is increment and decrement. Okay, students. Now we will see relational operators on pointer. I have two pointer again, P1 and P2. Let me run this. So P1 is, see the last values, address values 5088, 5092. So after operation, so here I compare P1 and P2. If P1 is equal to P2, then printf pointers are equal, or pointers point to the same memory address. In this case, it cannot be equal because P1 is pointing to X and P2 is pointing to Y. So this is going to be false. Same memory address. For illustration purpose, I am writing this. Okay. Else pointing to the different addresses. Different memory address. Okay. So what other relational operators we have? We have not. So if P1 is not equal to P2, then again you print the same message, point to the different address. Next compare. If P1 is greater than P2, you check this in this value which is greater 92, 82, 88. So P2 is greater than P1. So I can write here P1 is less than P2. Then pointer P1 has lower memory address than P2. So like this, if relational operators are true, then these messages will be printed. Okay. So now let me run this program. See, students, now the pointer P1 address is 128, P2 address is 132. After operation, pointers point to the different memory address. Of course, they cannot become equal because both are pointing to the different variables. So this statement is false, this statement become true, that is printed. Next, here also if P1 is not equal to P2, then pointing to the different address. Whether P1 is less than P2, yes, 128 is less than 132. Hence, this message will be printed. Pointer P1 has lower memory address than P2. So in this way, we can use pointers in relational expressions also. Understood, students? Now, let us understand what are the expressions which are not valid on pointers. Okay. So now, again, let me write this code. See this program. What I am doing here, I am taking two pointers P1 and P2. P1 is pointing to X, P2 is pointing to Y. So I am printing a statement, the addresses P1 and P2. After operations, what operations I am applying? P1 divided by P2, P1 multiplication P2, P1 divided by P3. What does this mean? P1 is the address. I am dividing the address of P1 divided by P2. Similarly, I am multiplying two pointer addresses. Also, I am dividing a pointer address by an integer. So, such type of operations are not allowed. They are invalid or illegal. So, let me demonstrate that through the program. See here, what message we got it. See, you can read this console messages. What is there? Error. Go for the error. Error. Invalid operands to binary divide. Okay, it is not allowed here. It is showing P1 divided by P2 is an error. Again, P1 multiplication P2, it is also an error. Also P1 divided by an integer, this is also an error. Understood, students? So such type of expressions are not allowed. Okay, fine. So these are the invalid operations on pointers. Let us understand some rules which are important on pointers operations. Following rules apply when performing operations on pointers. A pointer variable can be assigned the address of another variable. Okay, ನಾವು ಒಂದು ವೇರಿಯಬಲ್ ಅಡ್ರೆಸ್ ಅನ್ನ ಇನ್ನೊಂದು ಪಾಯಿಂಟರ್ಗೆ ಅಸೈನ್ ಮಾಡಬಹುದು. Pointer variable can be assigned the values of another pointer variable. Meaning is one pointer ಅನ್ನ ಇನ್ನೊಂದು ಪಾಯಿಂಟರ್ಗೆ ನಾವು ಅಸೈನ್ ಮಾಡಬಹುದು. A pointer variable can be initialized with null or zero values. So ಇದನ್ನ ನಾವು ಲಾಸ್ಟ್ ಸೆಷನ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. ಒಂದು ಪಾಯಿಂಟರ್ ಅನ್ನ null value ಕೂಡ ಇನಿಷಿಯಲೈಸ್ ಮಾಡಬಹುದು. A pointer variable can be prefixed or postfixed with increment or decrement operator. ಈಗ ತಾನೇ ನಾವು ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. This one. A pointer can be prefixed or postfixed, increment or decrement operators. An integer value may be added or subtracted from a pointer variable. This one. One pointer ಅನ್ನ ಒಂದು ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಆಡ್ ಮಾಡಬಹುದು ಅಥವಾ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಕೂಡ ಮಾಡಬಹುದು. So these are carefully observe these points. These are important points. When two pointers point to the same array, one pointer variable can be subtracted from another. The difference of these two pointers will give you the number of elements present in the array. In case of both pointers are pointing to the same array. When two pointers point to the objects of the same data types, they can be compared using relational operators. ಈ ಲಾಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಡೆಮಾನ್ಸ್ಟ್ರೇಷನ್ ನಾವು ನೋಡಿದ್ವಿ. ಎರಡು ಇಂಟಿಜರ್ ಟೈಪ್ ಪಾಯಿಂಟರ್ಸ್ ಅನ್ನ ತಗೊಂಡಿದ್ವಿ P1 and P2. ಅವು ಕಂಪೇರ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡಿದ್ವಿ ವೆದರ್ ದೇರ್ ಮೆಮೊರಿ ಅಡ್ರೆಸಸ್ ಆರ್ ಈಕ್ವಲ್ ಆರ್ ನಾಟ್, ವಿಚ್ ಈಸ್ ಹೈಯರ್ ಮೆಮೊರಿ ಅಡ್ರೆಸ್, ವಿಚ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಲೋವರ್ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅಂತ ಅನ್ನೋದು ಚೆಕ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ಓನ್ಲಿ ವೆನ್ both the pointers should be of same data type. P1 ಇಂಟಿಜರ್ ಇತ್ತು, P2 ಫ್ಲೋಟ್ ಇತ್ತು ಅಂತಂದ್ರೆ ನಿಮಗೆ ಕಂಪೇರ್ ಮಾಡಕ್ ಬರೋದಿಲ್ಲ. ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾಯಿಂಟ್. Next, pointer variable cannot be multiplied by a constant. We cannot divide or we cannot multiply it by the constant values. Understood? Pointer variable. Pointer value ಗೆ ನೀವು multiply ಮಾಡಬಹುದು. Pointer value ಗೆ ನೀವು divide ಮಾಡಬಹುದು. But pointer variable ಅನ್ನು ನೀವು multiply ಮಾಡಕ್ ಬರೋದಿಲ್ಲ or you cannot divide also. Two pointer variables cannot be added. This is also very important. ಎರಡು ಪಾಯಿಂಟರ್ಸ್ ವೇರಿಯಬಲ್ ಏನಿರುತ್ತೆ ಅವು ಆಡ್ ಮಾಡಕ್ ಬರೋದಿಲ್ಲ. ಹೌ ಯು ವಿಲ್ ಆಡ್? ಪಾಯಿಂಟರ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಮೆಮೊರಿ ಅಡ್ರೆಸ್. ನೀವು ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅಂತ ಯಾವ ತರ ಆಡ್ ಮಾಡ್ತೀರಾ? ಬರೋದಿಲ್ಲ. ಬಿಕಾಸ್ ದೋಸ್ ಮೆಮೊರಿ ಅಡ್ರೆಸಸ್ ಆರ್ ಫಿಸಿಕಲ್ ಇನ್ ನೇಚರ್ ಇನ್ ದ memory, computer memory. So you cannot add those physical memory addresses. You can add the pointer values, not the pointer variables. Okay, ಅದಕ್ಕೆ ನಾನು ಮೇಲಿನ ಸ್ಲೈಡ್ಸ್ ಅಲ್ಲಿ ಹೇಳಿದೆ ನಿಮಗೆ ಅರ್ಥಮೆಟಿಕ್ ಆಪರೇಷನ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಪರ್ಫಾರ್ಮ್ ಆನ್ ಪಾಯಿಂಟರ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ನಾಟ್ ಆನ್ ಪಾಯಿಂಟರ್ಸ್ ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ನೀವು ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಬೇಕು. A value cannot be assigned to an arbitrary address like this. Using such type assignment is illegal. Okay, students? So these are the important points in pointers arithmetic operations or expressions. Now let us study lab program 1. ನಿಮಗೆ ಲ್ಯಾಬ್ ಪ್ರೋಗ್ರಾಮ್ ಇದೆ. There you need to write a program to illustrate the use of pointers in the arithmetic operations. So ಈಗಾಗಲೇ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದೀವಿ. ಅರ್ಥಮೆಟಿಕ್ ಆಪರೇಷನ್ಸ್ ಯಾವ ತರ ಯೂಸ್ ಮಾಡಬೇಕು, ಎಡಿಷನ್, ಸಬ್ಸ್ಟ್ರಾಕ್ಷನ್, ಡಿಫರೆನ್ಸ್ ಅಂಡ್ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ವಿ. ದಿಸ್ ಪ್ರೋಗ್ರಾಮ್, this one, the same program you can use for your lab program. Data structure using C lab ಅಂತ ಲ್ಯಾಬ್ ಪ್ರೋಗ್ರಾಮ್ ಇದೆ, ಲ್ಯಾಬ್ ಸಬ್ಜೆಕ್ಟ್ ಇದೆ. ಅಲ್ಲಿ ಪ್ರೋಗ್ರಾಮ್ ನಂಬರ್ 1 ಫಸ್ಟ್ ಪ್ರೋಗ್ರಾಮ್ ಏನಿದೆ ಅಂತಂದ್ರೆ C program to illustrate the use of pointers in arithmetic operator. Okay students, so you can utilize the same program there. Next concept, we will study pointers and arrays. Till now we discussed pointers, arithmetic operations. Now we will study pointers and arrays. How can we use pointers with arrays? When an array is declared, compiler allocates the base address and sufficient amount of storage to contain all the elements of the array in contiguous memory location. Contiguous meaning ಏನು, ಸೀಕ್ವೆನ್ಸ್ ಆಗಿರೋದು. ಸೀರಿಯಲ್ ಆಗಿ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅನ್ನು ಇರೋದನ್ನು ನಾವು ಕಾಂಟಿಗಸ್ ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಅಂತ ಕರಿತೀವಿ. ಇದನ್ನು ನೀವು ಕಂಪ್ಯೂಟರ್ ಆರ್ಗನೈಸೇಷನ್ ಸಬ್ಜೆಕ್ಟ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಾ, contiguous memory locations and non-contiguous memory locations. Okay, so whenever an array is declared, compiler will allocate sufficient amount of storage in contiguous fashion. So every array is having the base address. Base address ಎಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, a of 0th element ಇಂದ ನಾವು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ array ದ ಇಂಡೆಕ್ಸ್ ಅನ್ನು. So 0th memory location will be the base address. Base address is the location of the first element of the array. So ಇಲ್ಲಿ first element ಯಾವುದಿದೆ, 1 ಇದೆ. Let me show you how this is organized in memory. So x of 0, x of 1, 2, 3 up to 4, that is n minus 1. N is the size of the array, that is 5 minus 1 will give the last index of the array, and values stored are 1, 2, 3, 4, 5. So let us assume compiler allocated the base address to this array is 1000. Okay, then we can represent that base address using this expression ampersand of 0, which is 1000. And if in case of we are using the pointers, and we can assign the array to the pointer. So ಯಾವ ತರ ನಾವು array ನ assign ಮಾಡ್ತೀವಿ, if p equal to ampersand x ಅಂತಂದ್ರೆ this is nothing but first 0th element ಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ. Otherwise we use the notation simply p equal to x. So p equal to x notation use ಮಾಡಿದೆವು ಅಂದ್ರೆ p is pointing to the entire address, entire array, right? So let me show you. We can access every value of x using p++ to move from one element to another. So this is the relationship between pointer and the array. That is, p is ampersand of x, 0th position, p+1 will give you the second position memory location, p+2 will give you the third location, p+3 will give you the fourth location, and p+4 will give you the fifth location or the last index location. So how to calculate? So address of an element is calculated using index and scale factor. This is important. Scale factor now important irutte address annu calculate ಮಾಡೋ ಟೈಮಲ್ಲಿ. For example, I want the index or address at this position x of 3. Then I have to write base address plus this number 3 into scale factor of integer. What is the scale factor of integer? 2, or I can write 4. 4 bytes or 2 bytes depends on the computer architecture. 4 bytes ತಗೊಳುತ್ತೆ, 2 bytes ತಗೊಳುತ್ತೆ. ನಾವು ಲೇಟೆಸ್ಟ್ 64 bytes ಅದೆಲ್ಲ ಎಷ್ಟು ತಗೊಳುತ್ತೆ, 4 bytes memory address ಅನ್ನು ತಗೊಳುತ್ತೆ. So this was 32-bit computer architecture will take 2 bytes for the integer value. In that case, 1000 base address into, this should be plus 3 into 2, which is 1006. So ಇಲ್ಲಿ ನೋಡಿ, p plus 3 which is ampersand of x of 3 which is equal to 1006 memory address calculate agide. Understood? So this star p plus 3 will move to the address 1006. In this way we can access the array elements using pointers. So here it is one simple program which access the pointers, which access the array elements using the pointer. So main logic the main logic of this program is here. By using the while statement, I is less than 5, print the array elements and sums up I plus plus and p plus plus. This should be p plus, incrementing the pointer. Okay, students. So you can execute this program in your computer. Take it as an assignment. Now let me show you how the array elements are represented in memory. So my array is this one, whose elements are 57298 with the base address 80,024, 28, 32, 36, 40. Like this, the first element is stored at the address 24, second 28, right? So I can access every element by incrementing the pointer. Okay, pointer plus plus. Here, this is the in code. This is the operator where p is getting incremented. Okay, students. Now, pointers and two-dimensional arrays. Pointers can be used to manipulate two-dimensional arrays. We know that one-dimensional array A expression, that is a plus I or p plus I, represents the element x. ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ ನೋಡಿ, p plus 3, where I3 can be represented as I. So a plus I or p plus I, both are same. Similarly, two-dimensional array can be represented using the pointers through the following expression. So ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕು, ಡಬಲ್ asterisk operations ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು enclosed between double parentheses. So first one will indicate the array element at the position p plus I, where the entire expression will represent you that the element together this element present at ith row and jth column. See this one. So this represents the row and this line represents the columns. So here are different indicators. By this notation you can understand the meaning of this one. Just p pointers to the first row, p plus I pointers to the ith row. That ith may be from 0 to 7. Star p plus I represents the first element in the ith row, whereas star p plus I plus j pointer to the element in the ith row. Similarly, value stored in the cell ij, that is ith row, jth column. So in this way we can access two-dimensional array elements using the pointers. Okay, students. So now we will stop the session. We'll wind up it. If you have any doubts regarding the pointers arithmetic operations or using pointers in arrays, that is one-dimensional array or two-dimensional array, you can write us at the email ID lms.dtk@gmail.com. Thank you for watching this video.